All right, so graphing piecewise functions. So a function that's defined by two or more equations is called a piecewise function. So to explain this concept, I'm going to go ahead and show you an example of a word problem. So a cell phone company offers the following plan. $20 per month will get you 60 minutes. Additional time will cost you 40 cents per minute. We can represent the plan, um, this plan mathematically by writing the total monthly cost C as a function of the number of calling minutes T. So depending on how long you talk, we're going to define it as two different functions. So right here, your cost is going to be $20 if you talk somewhere between 0 and 60 minutes. That's that first $20 that you're buying for 60 minutes. You either use it or you don't. But if you go over that 60 minutes, then here's your new cost equation. So you pay that initial $20 and then plus 40 cents for every minute that goes over 60. So T, if it's greater than 60, subtract 60 multiplied by 40 cents to pay that additional charge. And then here's a graph of that right there. Okay, now we're not going to be working word problems, but that's just to kind of give you an idea of how this could be useful. Okay, so right here it says for the piecewise function, find the specified function values. So g of x is equal to, we have x plus 4. Now that's for when x is less than or equal to 1. If x is greater than 1, then we actually will plug it into 8 minus x. So whenever you plug in a value, you'll never plug it into both. It's one or the other. And so what's going on here, try to give you a little picture of this. Okay, so I'll do this top one in red. So right here at 1, anything that's less than or equal to 1, you're going to plug into the top one, the first one. If you have anything greater than 1, so I'll use a little parentheses right there, you'll plug it into the second function right here. So g of negative 4 would lie in the red area, so we're going to plug it into uh, the first one. So g of negative 4 is going to be equal to negative 4 plus 4, which equals 0. Okay, then let's see. Now we'll do g of 0. 0 would be in the red part again. So g of 0 is equal to 0 plus 4. That will equal 4. Okay, g of 1, that one's a little tricky because it's right on the border between the two intervals, but the bracket's going to win out here, so we're still in the red area. So that'll be the top one. So g of 1 is going to be 1 plus 4, which equals 5. And then the last one, g of 3, obviously 3 is going to end up here in the blue, so we're going to plug it into our second one. So g of 3 equals 8 minus 3, which is 5. All right, let's try another one. We'll try one with 3 functions. So we're going to only work with 2 and 3, but you could go 4, 5, 6. It could go unlimited. But that's what we're going to mainly focus on. Okay, so for f of x, we have these 3 different functions that define it. And then these are our parameters right here. So if x is less than negative 2, if x is between negative 2 and positive 4, and then the last one is if x is greater than 4. Now, once again, we can kind of make a number line to kind of help us out here to kind of keep track of this. You don't have to do this, but might help. So negative 2, everything less than negative 2. Then in blue, we get to include these endpoints. So you include negative 2 all the way to 4. And then everything beyond 4 will go to the bottom one. All right, so let's go ahead and check these out. So on this first one, let's see, f of negative 4. Negative 4 would end up here in the purple. So f of negative 4 is equal to, so we're going to have negative 5 times negative 4 minus 8. So that'll give us 20 minus 8 is 12. And then let's see, our next one's f of negative 2. And so f of negative 2 is right there. You can see that it's part of the included endpoint for the blue interval. So that means we're going to plug it into our second one right here. So 1/2 times negative 2 plus 5. So negative 1 plus 5 is 4. And then let's see, f of positive 4. Let's see, once again, it's right here between the two intervals, but the blue one has the bracket. So we're going to plug it into that middle one again. So f of 4 equals 1/2 times 4 plus 5. So we're going to get 2 plus 5 equals 7. Okay, and then our last one, let's see, f of 6. Let's see, that's going to fall into the green interval, so that's going to go to our bottom equation. 10 minus 2 times 6. 10 minus 12 is negative 2. Okay, so now what we'll do is we're going to graph a couple of these. Okay, so the domain of these piecewise functions are going to be from negative to positive infinity. That means that the graph will go left and right completely. Okay, so what we're going to do is go ahead and graph them and then figure out the range, which is bottom to top. And so that won't be the case on all of these, that it will be from negative to positive infinity. So we'll just have to take a look. Okay, so the way I like to do this is, so we have f of x is equal to 2x if x is less than or equal to 0, and then the other one's going to be f of x equals 2, and that's going to be if x is greater than 0. So you can see right there, that's where the two intervals bump up against each other. So what I'm going to do is I'm going to label this one as y1, so when I make my table, I can kind of keep track of which one I'm looking at. So I need to pick some values that are less than or equal to 0. So I'm going to go ahead and start. You always want to start with the value that the inequality is with your variable, with your parameter. So I'm going to start with 0, and then something else that's less than or equal to 0, like negative 1, negative 2. All these are going to be lines. That won't always be the case, but for what we're going to be doing, pretty much we can focus on just lines. So let's see, I'm going to plug in 0. So 2 times 0 is 0. 2 times negative 1 is negative 2. 2 times negative 2 is negative 4. So let's go ahead and plot those points. So 0, 0, negative 1, negative 2, negative 2, negative 4. And then draw that and put an arrow on the end because it goes indefinitely down and to the left. Now the second one, we'll call that one y sub 2. Okay. Now when you build your table here, you might be thinking, okay, well, 0, it's got to be greater than 0, so I can't use 0. But we do actually want to start at 0, and I'll explain why in a second. So we will include 0, and then a value greater than 0 would be like 2, 3, whatever, right? And so what's going on here is this one's a constant function. Y is just going to equal 2. It doesn't really matter what x is as long as it's greater than 0. Now, like I said, we included 0, even though that's not going to be included point, and we'll talk about that in just a minute. But I get 2 back for all of these. Now, the reason I include 0 is because what about if I start at 1? A lot of students will start at 1, so they'll have a point at 1, 2, and they'll do it like this, and they'll be like, yay, and they'll draw their line. But the problem is you're missing out on all these points between 0 and 1, because, point 1, you would get a 2. 0.01, you would still get a 2. So you want to actually include, well, we're not going to include it, but we want to put this point on the graph as an open circle. So we're going to put an open circle right there at 0, 2. And then we can connect that to where now we're getting all those points that were between 1 and 0. So when you create your tables, even if it's not included, go ahead and put it in your table and just kind of make yourself a little note that it's going to be an open circle. And that's how all these graphs are going to be. you're going to have one that's closed and one that's open where they begin and end. Okay, so where this one ended, it was closed. This one began and started open, and it could be vice versa sometimes. Okay, but there will always be one open and one closed right there. All right, so here's another. Oh, almost forgot to do the range. Okay, so the range on this one, so from bottom to top, so it's not bounded below, it goes down indefinitely, so that's going to be negative infinity, and then it comes up and it stops right there at 0, but then it jumps up here to 2, and you just have 2 repeating over and over again for your y value, your range. So union 2. So that would be our range for this graph right here. So from negative infinity up to 0, then 2 also is included. Okay, so on the second one, so once again, if we want to kind of keep track of this, we can label these. So let's see, that'll be my y1. So y1 is going to be x plus 3 if x is less than negative 2. So we'll go ahead and make a table. So even though negative 2 is not included, I'm going to go ahead and put it right here, negative 2, and then some other values that are less than negative 2, like negative 3, negative 4, and so on. So I'm going to plug it in here and add it. I'm going to add 3 to it. Negative 2 plus 3 is 1. Negative 3 plus 3 is 0. Negative 4 plus 3 is negative 1. Now, once again, you might want to make a little note here. That point right there is actually not included, so we're going to use an open circle at negative 2 up 1. Okay, and then 3, 0, negative 4, negative 1. And you could just kind of continue that pattern out right there. And there we go. There's the first one. Now we'll look at our second one. We'll call that one y2. So x, y2. So then let's see, we want to pick out values that are greater than or equal to negative 2. So you always want to start at whatever that value is, even whether it's included or not. This time it is, though. So negative 2, and then value greater than a negative 2 would be like 0 or, 4, whatever you want to pick. Just values greater than or equal to negative 2. So we're going to go ahead and subtract 3 from that. So negative 2 minus 3 is negative 5. 0 minus 3 is negative 3. 4 minus 3 is 1. So let's see it. Negative 2, we're down here at negative 5. That is included. So see, 1's open, 1's closed. Let's see, 0, 3. And then at 4, we're up here at 1. All right, so let's go ahead and draw that. There we go. Okay. Now, the range on this one can be a little tricky. Kind of throws students off a little bit. They get a little confused with what's going on here. But if you look, this one goes down indefinitely. This one goes up indefinitely. And then there's some overlap in the middle. But basically, if you look at this, all the range values are covered from bottom all the way to top. So see bottom, this goes down indefinitely, and it goes up and it stops right there. But this guy can take over and continue to go up over here. So really, it's going to be everything from negative to positive infinity. So all real numbers. All right, let's try one more. Okay, so both of these are going to be constant functions, as you can see right here. So f of x equals 3 if x is less than or equal to negative 1. F of x equals negative 3 if x is greater than 1. So let's go ahead and make a table for this. Once again, we can label it to try to keep track of this a little bit. Okay, so values less than or equal to negative 1. So negative 1, negative 2, negative 3, whatever you want to do. And so you just get that constant 3 back, 3, 3, 3. Now, negative 1 is included, so we'll have a solid point right there. Okay, and then negative 2, and negative 3, and so on. That pattern would continue on, so you have all those values right there. Then the second one, we'll call that one y2. So y, x and y2. So here we want to pick out values greater than -1. So even though -1 is not included, we're going to put it in our table. So -1, something greater than -1 would be like 0, 1, 2, 3, whatever you want to use. And so you constantly get back -3, -3, -3, -3. And then -1 actually is not part of the parameters here, but we're going to go ahead and put an open circle there to remind us that. So at -1, -3, we get an open circle, and then 0, -3, 1, -3, and so on and so on. And so that pattern would continue out that way. Last thing to look at is the range. So if we look at the range on this one, okay, um, it doesn't go down indefinitely. It just stays at 3, and then I'm sorry, -3, and pops up to +3. So those are your only two y values that come out of this, and that's your range. That's what range is. It's your y values. So it's going to be -3 and +3. That's it. That's your range. Just those two numbers, and that's it.